Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we are required to evaluate the orthographic projections of a line which happens to be perpendicular to the vertical plane and parallel to the horizontal plane. So here we have got the line EF, which is 50 millimeter long, and this line happens to be perpendicular to the vertical plane and parallel to the horizontal plane. And the end E of the line, it happens to be 20 millimeter above the horizontal plane and 15 millimeter in front of the vertical plane. And we are required to draw over here the front view, top view and the left hand side projections of this particular line EF, and we are also required to locate the traces of this particular line EF. Now let us first of all discuss the spatial location or the orientation of the line with respect to horizontal plane, vertical plane and the profile plane. So here we have got the horizontal plane and the vertical plane. So the intersection of the horizontal plane and the vertical plane will provide us with the XY reference line. So here we have drawn this line EF 50 millimeter long, perpendicular to the vertical plane and parallel to the horizontal plane in such a way that one of its end E, it is 15 millimeter away from the vertical plane or in front of the vertical plane. And this end E of the line, it happens to be 20 millimeter above the horizontal plane. So this distance, that is 15 millimeter in front of the vertical plane, we have located in order to position point E of this particular line. And then this is the 50 millimeter length of the line EF. Now, having located this line in space, when we are going to observe this line from the top, then we are going to observe the true length of this line EF onto the horizontal plane in the top view projection. Now the reason is, we know the simple fundamental of projections of the line, that is, whenever a line it is parallel to a given reference plane, its projection on that reference plane will provide us with the true length or the true image of this line onto that particular plane. Now since this line happens to be parallel to the horizontal plane, so first of all the projection which we are going to obtain to begin with will be the top view projection. So in order to obtain the top view projection, the observer is going to look at this particular line from above. So the projections which will be obtained on the horizontal plane, they will be EF projections over here. Now, once we obtain the projection of this line EF onto the horizontal plane in the top view, so we will observe that the length of this projection EF in the top view will be 50 millimeter. That is, it will represent the true length of the line in the top view projection over here. Now, when the observer is going to look at this line from the front, so the ends F and E, they are going to coincide with each other because this line happens to be perpendicular to the vertical plane. So whenever a line it is perpendicular to a given reference plane, its projection on that particular plane will provide us with the point view projection of this particular line. So we can see over here ends F and E, they are going to coincide with each other in the front view projection over here, which will be obtained onto the vertical plane. So we have been able to obtain F dash and E dash projections at a height of 20 millimeter above the ground or 20 millimeter above the XY reference line. And both of these points F dash and E dash, they have converged with each other or they have coincided with each other. So this way we have obtained the front view, point view projections of this line F dash, E dash onto the vertical plane, and we have also obtained the top view projections of this particular line, that is EF, onto the horizontal plane, which are the true length projections. Now once we draw this construction line and this construction line, so we will be able to establish the relationship between the front view and the top view projections of this particular line. So having obtained these two projections, now let us locate the traces of the line with respect to the two reference planes, that is HP and VP. Now since this line happens to be parallel to the horizontal plane, so this line EF, it is not going to intersect with the horizontal plane, so it will not have any horizontal trace available over here. While this line EF, it happens to be perpendicular to the vertical plane, so the intersection of this line itself or its extension with the vertical plane will provide us with the vertical trace of the line. So when we extend this line EF onto the vertical plane, we find that the extension of this line will give us the intersection of this extension of the line with the vertical plane, and the point V dash will be located in the front view projection over here. So having located this point V dash in the front view, now we are required to draw perpendicular from this point V dash onto the XY reference line. So once we draw this perpendicular projector downwards onto the XY reference line, we are going to obtain the intersection of this vertical projection with the XY reference line as point V, because this point V, it is existing on the extension of the plan projection EF over here. So that is why the name of this point will be small v. And now this perpendicular distance between the intersection of the plan projection extension onto the XY reference line and the point V dash, which has been obtained in the front view. So this distance V and V dash, so this will provide us with the vertical trace of the line. So we will see that the vertical trace of this line happens to be 20 millimeter. So VT is the distance between point V and V dash, which is equal to 20 millimeter. Now we have drawn the front view, the top view projection, as well as the vertical trace. Now let us proceed with the construction of the left hand side view projection of this particular line EF. So whenever the observer is going to look at this particular line from the left hand side, the projections of this line will be obtained on the profile plane, which is located on the right hand side over here. Now we will see that since this line happens to be parallel to the horizontal plane, so this line will in turn be parallel to the profile plane as well. Now since this line, it is parallel to the profile plane, so the projections of this line, while the observer is going to look at this particular line from the left hand side, so these projections obtained on the profile plane will provide us with the true length projections of the line in the left hand side view. So just see that observer is looking at this particular line from the left side. So E point will be projected over here as E double dash. F point will be projected onto the profile plane at point F double dash. So E double dash has been obtained in the profile plane. F double dash point has been obtained in the profile plane. Now we can join the E double dash point with the F double dash point, and we will be able to obtain the true length projections of the line in the left hand side view projections, which are obtained in the profile plane. Now having obtained the left hand side view projections in the profile plane, now we are required to establish the relationship between the left side view projections and the top view projection. So this will be done by drawing these two projection lines over here. So this projection line and this projection line, once we draw, so the relationship between E double dash and point E will be established. Similarly, draw one perpendicular line from here, draw another construction line over here from point F. So once we draw these two construction lines, so we are going to obtain the relationship between F double dash and point F over here. So the side view projections and the top view projection, they are correlated with each other. Similarly, we have to establish the relationship between the left hand side projections obtained on the profile plane with the front view projection. So please check. Again, two construction lines we are required to draw over here. One through the extension of E double dash, F double dash, and another one parallel to the XY drawn through the points F dash and E dash. So this construction line, it is parallel to the XY reference line and it is drawn through F dash and E dash. And this one, it is the extension of the true length which is obtained in the profile plane. So this way we have been able to establish the correlation between front view, top view and left hand side view projections which have been shown in the 3D spatial coordinate location over here. Now let us proceed with the construction of the orthographic projections of this particular line EF. So here we have got vertical plane, horizontal plane and the profile plane over here. Now we know that first of all projections will be obtained on the horizontal plane. Why? Because this line happens to be parallel to the horizontal plane and it is perpendicular to the vertical plane. So first of all, we know that the first projections that we are going to develop, that is orthographic projection, they will be top view projections which are drawn or obtained onto the horizontal plane. So we know that this horizontal plane, it contains this true length projection of the top view which is 50 millimeter, and this end E, it is located 15 millimeter in front of the vertical plane. This distance 15 millimeter we have marked over here. So having marked this 15 millimeter distance using a construction line, now we can draw true length of this line EF which is equal to 50 millimeter. So this is the true length projection of this line which is obtained onto the horizontal plane. So this projection EF has been drawn in the top view projection, that is onto the horizontal plane, and this represents true length of the line in the top view. So having obtained the top view projection, now let us proceed with the construction of the front view projection. So we know that as the observer is going to look at this line, so both of these points E and F, they are going to coincide with each other and we will be obtaining points F dash and E dash as a point view 20 millimeter above the XY reference line in the front view. So the front view projection will be a point view projection F dash, E dash. So the distance between E dash and F dash will be 0 so that we obtain a point view projection, and both of these points, they will be located at a height of 20 millimeter above the XY reference line or above the horizontal plane. So now we are going to mark this distance as 20 millimeter, and once we mark this distance as 20 millimeter, this point, that is F dash and E dash, so this represents the point view front view projection of this line which is obtained onto the vertical plane. Now we have obtained the true length top view projections, the point view front view projections of this particular line. Now let us proceed with the location of the trace of the line. So as we have discussed, since this line happens to be parallel to the horizontal plane, so it won't have any horizontal trace because it is not going to intersect with the horizontal plane. So since this line, it is perpendicular to the vertical plane, so it is going to intersect with the vertical plane, so we are going to get only the vertical trace of the line. So in the projections over here, so we will see that we have to extend the plan projection line over here till it meets the XY reference line. So we have to extend this plan projection line EF till it intersects with the XY reference line, and from here we are required to drop a perpendicular projector onto the front view apparent length or the point view projections of this particular line. Here we have got EF as the plan projection length of this particular line. So is this plan projection length intersecting with the vertical plane? No. So we have to get the extension of this plan projection line till it intersects with the XY reference line. So this will give us the location of the point V. So this gives us, please check, as I extend this plan projection line up to the XY reference line, we obtain the location of the point V, and from this point V, we will be dropping perpendicular onto the elevation point view projections of this particular line. So from point V, we are going to drop a perpendicular onto the projection point view of this particular line, which happens to be F dash and E dash. So this intersection gives us the point V dash. Now the vertical trace of the line, it is the distance between point V dash and point V over here. And this happens to be 20 millimeter once again. So having obtained the front view projections, top view projections and the vertical trace of the line, now let us proceed with the construction of the left hand side view projections of the line onto the profile plane. So in order to obtain the left hand side view projections, so we have got 2 points over here in the top view projection. So we need to draw horizontal locus line through the point E and through the point F onto the X1 Y1 reference line. And now using the circular transfer lines through points E and F over here. So we are going to obtain this distance of 15 millimeter and this distance of 65 millimeter onto the left hand side view projection over here. So we'll keep our needle point as the intersection of the reference lines XY and the X1 Y1. So this distance of 15 millimeter corresponding to the point E in the plan. So this will be transferred onto the profile plane projections over here in this way. That is, keep your needle here. Open compass is equal to this radius of 15 millimeter. Draw an arc so that this arc should intersect with the XY reference line. So this distance of 15 millimeter in front of the vertical plane has been transferred onto the side view. Similarly, the distance of the point F from the XY reference line, this is 65 millimeter in front of the vertical plane. So once again, we'll keep our needle point at the intersection of the XY reference line and the X1 Y1 reference line. Open compass is equal to radius 65 millimeter. Draw an arc so that this distance of 65 millimeter is converted into this sideways distance alongside this particular profile plane. Now we have got the distances in front of the vertical plane transferred into the profile plane. Now from these 2 points, again vertical projectors will be drawn upwards over here. Now we have to draw a horizontal locus line from the front view projection points E dash and F dash in such a way that they should be intersecting with the corresponding vertical projectors we have drawn through the point E and the point F. So this is vertical projector through the point E. This is vertical projector drawn through the point F over here. So wherever the horizontal locus line through the point E dash, it intersects with the vertical projector line which is appearing corresponding to the point E. So this point will give us the location of point E double dash. Similarly, wherever the horizontal locus line emerging from the point F dash, it intersects with the vertical projector line which is drawn corresponding to the point F over here. So this is the vertical projector line which has been drawn corresponding to the point F. Why? Because you can see from point F we have drawn the horizontal locus line. This is our circular transfer arc which we have drawn over here, and then this is the vertical projector line. So wherever this vertical projector line corresponding to point F, it intersects with the horizontal projector emerging from the point F dash, we obtain the point F double dash. So E double dash in the side view point has been obtained. F double dash point in the side view has been obtained onto the profile plane projections. Now, if we join E double dash with F double dash, we will find that the left hand side view projections which we have obtained, they will be representing the true length projection of this particular line. So this way we have been able to develop the top view true length projections, the left hand side view true length projections, and the front view point view projections of this line EF, which is perpendicular to VP and parallel to the horizontal plane. And besides this, we have also evaluated the traces of this particular line. So this is all for today. So I hope that through this discussion you would have understood about how we can spatially locate the line EF in the 3D coordinate system using horizontal plane, vertical plane and the profile plane, and how to obtain the projections of this line in the 3D spatial coordinate location as well as in the orthographic projection system, that is 2D projection system. So we have developed the front view projections, the top view projections and the left hand side view projections of this particular line, and also located the traces of this line over here. We are going to continue with further discussion on few more illustrative cases regarding the orthographic projections of the lines in the coming lectures. Thank you very much. Thanks a lot.